Hi everyone. I'd like to thank you for connecting into our webinar, How to Build Higher Quality Apps Through Testing. My name is Michael Germann. I'm the Senior Developer for the Infragistics Test Automation for HP products. I can be reached at testautomation@infragistics.com. While I'll be answering questions live, if you have any questions after the webinar, have any feedback or future ideas for any of the test automation products, or even for the future test automation video topics, feel free to contact me there. For our agenda today, we're going to start with a brief introduction to automated testing. Here I'll record and replay a simple script, then expand on it from there with some hand scripting, and further still by making it data-driven. Once you can see the value of automated testing, from there we're going to go back a step and show what you need to test your application with Infragistics Test Automation, and how to determine what version you will need with your application. Once you have Infragistics Test Automation for HP up and running, I'll demonstrate that we add more than just simple record and replay support for our custom controls. We'll go over some of the additional functions that we've added. Finally, we'll delve a bit into the differences between test automation for HP and test automation for IBM. So let's get started. Okay, so let's just jump right into a simple automation script then. What I have here is a blank script on HP's unified functional testing software. I'm going to go to the record menus, record and run settings, and tell UFT what application I'm going to test with, and then start recording. UFT will automatically open the application that I selected. For this sample test case scenario, I'm going to test the calculated values at the bottom, which are calculated based on the data in the grid. To do that, I'll record some changes in the grid. After that, I'm going to add some verification points. I'm going to go up to the design menu, select checkpoints and standard checkpoint, or F12. It'll give me a hand cursor to select the UI control that I want to put on a verification point. I'm just going to verify the properties that I want to test and click OK. I'm going to add one more checkpoint using F12 instead of going through the menu. This one will be on the % markup editor on the bottom of the application. That's it, we're done recording. I'm going to close the application, hit stop. Now all that is left to do is click run and watch. UFT will reopen the application and run through the script, changing each value as it was recorded. Then when the script is complete, it will open up the Run Results Viewer. The Results Viewer has a line for each step in the script, as well as reporting that the checkpoints have passed. Expanding those checkpoints, you can see each property that I've checked along the way. I'm just going to close the Run Results Viewer, close the application, and the next thing I'm going to demonstrate is what happens when you get another version of the program from your developer. I'm going to go back to the record and run settings, remove the original application, and change it to version 2. Now I'm just going to hit run. With this new application, it's styled a little differently. Some of the controls are different spots, but otherwise it's the same application. Now that the script's complete, the run results will pop open. You can see by the red X's that something didn't happen right. So let's expand it open. Now all the steps ran through. The first checkpoint passed okay. We can take a look, the value is fine. Opening up the % markup, we can see that it was formatted differently. This is a common enough style error, but before we get into adjusting for it, let's close the Run Results Viewer and application and clean up the script a little bit. First thing I usually like doing when cleaning up a script is taking the objects and creating variables out of them. So in this case, I'm going to create one for the grid. I'm just going to say set grid and copy in the part I recorded earlier. Now I can start using that object just by doing grid. I also create an array of values. This one's going to be for the values that we actually set. Since we only really set 5 different values, I'm just going to create a quick array, throw those 5 values in. With that, I can just make a quick for loop. I'm just going to do for row, because that's what I'm representing, from 0 to 4, because we had rows from 0 to 4 that we modified. Now inside the loop, I can do grid dot, and we're going to pick an action. In this case, it's going to be set cell data. You can see that it had IntelliSense, I'm going to use row, the column is price, and it will take the value from the array values of row. Now we can just cut that and replace all this code that we recorded earlier and have pretty much the same outcome. While the script's a little cleaner, the results are going to be the same. I'm going to go to the object repository, and from there I'm going to select the checkpoint for % markup and look at the value. I could change it to the value that the other one was. In this case, it's 219% or 219.4836%. And just close the repository and hit run. This time it should run a little quicker because instead of running all the extra steps that it recorded, it's just going to run the set cell datas, which usually run a lot quicker because it's just setting the data directly. Now the checkpoint's done. We'll run results viewer opens, and we see it passed entirely. Now I'm going to take it a step further by making it a data-driven script. Let's start with a clean script. I'm going to go to Start Page, select the script name, just revert the changes back, that's fine. Now I'm going to add a new action. This is where most of the action is going to happen. I'm setting this to after the current step so that we can see the action call in our script. It'll automatically give focus to the new child action, but before we get started I want to go back to the root action and change the what iteration to all iterations. With that done, I'm going to go back to my child action and start setting the data. I'm going to pull up the Data tab, and in there I'm pasting in 3 columns of data. The first 2 are the data from the data source of the application that we were using. The third is a percentage I want to modify the unit price by. UFT allows many of the Excel functions to be used, so I'm going to make a few custom columns that are going to be derived from the first 3. The first is going to be a newly adjusted unit price. The next 2 are going to be the units ordered multiplied by the old price and by the new price respectively. Lastly, I'm going to create a column that is essentially the new total cost of the order as it applies to the current row and all the rows up to it. Now I just need to paste in the formulae to cover all the rows. Speaking of which, actually one more column I want to add is for the current row number. And I can see because how I made the formula, I need to modify the last one to remove the second summation. Now we can give the columns meaningful names that we can reference in our script. With the data set up, let's hit record and open up our application. Here I am just clicking in the grid to add it to the object repository, and since by design of the application the editors are not allowed to take focus and therefore will not record, I'm going to add a checkpoint to add it to the object repository. With the 2 objects I want to test against added, let's stop recording and start scripting. As before, I'm going to set the grid to an object variable for ease of manipulation and readability. I'm also going to add one for the row, as it will not be an object but an integer. I don't need to use the set to define the variable. I'm going to use a data table method passing in the column name and DT local sheet to tell it to use the current action sheet. With that done, I can script one line of easily readable code that sets the unit price cells data to the column from the data table. Lastly, I'm going to make a simple check property checkpoint. This is useful if you're just checking one property from the UI control. In this statement, I'm going to compare the value property from the UI control to the calculated total column from the data table. The script is now complete. I can hit run and see how it plays out. You can see as it runs through the script, setting the cell value to the data from each individual row in the data table, even though I only scripted a few lines of code. Now that the script's complete and a Run Results viewer opens up, we can see an entry in the results for each iteration, as well as an entry for each of the checkpoints. This shows the power of being able to script a few lines of data-driven script to test a large number of test cases in a small amount of time. Now that you see what test automation can do, now it is time to show you what you need to make Infragistics Test Automation work for you. To start off with, Infragistics Test Automation is not a standalone product. It is an add-in to existing third-party test automation software packages. The reason for this is Infragistics makes custom user interface controls, or UI controls, and the existing third-party test automation software packages only reliably support the inbox controls for Visual Studio. Thus the need for Infragistics to create the test automation add-ins so that it would be possible to automate tests involving Infragistics UI controls. The first of which was a testing software by HP. We've been partnered with HP since they acquired Quick Test Professional, or QTP for short, back in 2006, and we've been fully integrated with our Windows Forms controls every release of QTP since. At the start of 2011, we also integrated our WPF suite of controls with QTP. Unified Functional Testing Software, or UFT for short, was created as a combination of two of their testing product lines, QTP and HP Service Test, into a single software package, hence the name change. In respects to Infragistics Test Automation, and UI automation in general though, it doesn't affect our integration as it effectively is QTP 11.5. With the new and changing technologies, be it the release of new .NET runtimes or the 64-bit architecture, patches for QTP and UFT are required to support our current set of UI controls in all environments. The minimum patches, which are on the slide, are available from HP upon request. There are newer patches for both QTP and UFT, but they are not required to work with Infragistics Test Automation. By customer demand, in 2007 we also integrated our Windows Forms controls with IBM's Rational Functional Tester, or RFT for short. RFT itself is an add-in to either Microsoft Visual Studio via VB.NET or Eclipse via Java, as it requires an external IDE to work correctly. Where HP uses a VB script-based coding model with highly discoverable API-style methods and properties, RFT instead uses an in-depth subitem-based model that allows for a more precise level of control during scripting. RFT also incorporates an extensive list of predefined verification points with the ability to drill down the entire object model of the controls to verify any piece of data. Now that you know about the two testing software packages that we integrate with, which product you use depends on what platform of controls you're using. In the case of Windows Forms controls, you can use either, so it's your preference. In the case of WPF controls, though, we only support HP at this time. The next step, assuming that you're already using Infragistics UI controls and have your third-party testing software as well, is trying to determine which version of Infragistics Test Automation that you need. The major factors for determining what test automation you need can be determined by the Infragistics UI assemblies being used in your application, as you must have the matching version of IG Test Automation with that of the UI controls in use. In most cases, you can get all the information you need by just looking at the assembly file name. In respects to a platform, if it has .win. Inside the name, it is part of our Windows Forms controls. Likewise, if it starts with Infragistics WPF, it is part of our WPF control suite. In respects to versioned or version-free, most of the developers are using our version set of assemblies. You can tell them easily enough if they have the major and minor version numbers built into the assembly names, such as V11.2 for our 2011 Volume 2 suite of controls. Similarly, which CLR the assemblies are built on is built into the name as well. For example, Infragistics 2 for CLR2 and Infragistics 4 or Infragistics WPF 4 for CLR4. While currently all of our controls are CLR4 and have been for over a year, each release of a new .NET runtime, or CLR, that incorporates a major change such as from CLR1 to CLR2 or CLR2 to CLR4, we offer two versions of the assembly side by side for a time. Determining the version number or CLR for version-free assemblies will require you to interrogate the assemblies further though. To determine the major and minor version numbers, you will need to get the file version or product version number from the assembly. Only the first two dotted numbers matter at that point. In respects to the CLR or version-free assemblies, we only ever supported the most current .NET runtime at the time of release. The chart on the side shows which CLR corresponds to which release. I'm just going to do a brief demonstration on how and where you would likely get the assembly information. Here I'm using Windows Explorer to find the application in question, and you can typically find the assemblies either in the same directory as the application or under the bin folder. In the case of an application using version-free assemblies, you can either right-click and get properties of the assembly. When the Properties dialog is open, select the Details tab, and you can find them there. Or you can right-click on the column header area, select More, and in the tree, scroll down to the file version and check that. Click OK, and it'll show it in the columns. In some cases, though, you may have trouble finding or definitively determining what assembly goes with your application. It may be that several applications are in one directory with multiple versions of the assemblies, or you can't find them as they're referenced from some obscure location. They could be built into the application, or in this case, in the Global Assembly Cache, or GAC for short. In any of these cases, you can use Process Explorer. It is a freeware application by Microsoft. Among the many things it does, the most useful in terms of IG test automation is in its ability to interrogate the load assemblies of an application. The application in question must be running, and if you cannot find it in the process tree, you can always use the crosshairs button tool and click on your application. It will find it in the tree for you. Once selected, look in the lower pane view. It is easiest to find if sorted. Scroll down and find the Infragistics assemblies. Once found, you can see the version number corresponding to it. If the lower pane view is not visible, you can select from the View menu Lower Pane View and DLLs, or Control-D for a hotkey. Also, if the version number is not visible in the lower pane view, you can right-click on the column header, select DLL tab, and check the version number from the checkbox. Some of the most common configuration issues with Infragistics Test Automation can be determined and often resolved by what you find in the loaded assemblies of an application. If while recording you have an unexpected error, or it fails to record or replay at all, or in an unexpected manner, load up your application and Process Explorer and see what assemblies are loaded. You can also use this immediately after recording or replaying, as long as your application is still open, and see what test automation assemblies were loaded in your application. If they do not match the UI control assemblies, that is most likely the issue. Within IG Test Automation for HP development, we try to always add the greatest value by adding the most concise actions. As test automation for HP is an API-based model, wherein all the actions and properties must lie solely on the UI control level, these must cover all scenarios for that control, regardless of its size or complexity. This can present a challenge. How to cover as broad as support for all the possible UI actions for that control, without burying the end tester in too many methods to sort through. Invariably, for some of our larger, more customizable controls, an edge case will slip by. It is for these scenarios that we added our properties access methods. GetAnyProperty, one of our earliest features and the basis of all our property access methods, allows you to pass in C# style property access strings, and it will return the appropriate value or object. It should be noted that while all object types can be passed back, some may be effectively inaccessible for HP's VB script. Thus, it is highly recommended, when dealing with complex object types, to pass in a larger property string so that you can dig deeper to a value type and do your checks and comparisons with them instead. SetAnyProperty is similar to GetAnyProperty in that you can pass in any depth of property string, but allows you to pass in one value type to set that property value to. Finally, there is GetAnyProperties. Similar to GetAnyProperty, it allows you to retrieve all the properties for a given object. You can pass in nothing to get all the properties for the UI control, or pass in any depth of property string and retrieves all the properties of that object. While possibly not as useful in a final test script scenario, it does offer the tester the ability to interrogate an object and learn about it when no reference material is available. Recently, we have begun to expand the functionality of these three methods by creating custom properties. These were added initially in our WPF product, but are now in the process of being expanded into our Windows Forms product as a way to expose relevant data that would otherwise be more difficult or impossible to retrieve. The example to the side is a message box statement called on the getAny properties action on a XAMPP grid. You can see a number of custom properties have been implemented. Some simple ones like type and toString have been added to all objects just so that you can more easily interrogate them. The subsequent custom properties are exposed on all objects of type framework element. For some of them, to get even via code inside your application could take extensive coding. We do the work for you. The properties children and child count are excellent for digging deep in the visual tree, especially since most of the subsequent child elements are also framework elements. The properties x, y, height, width, and rect are great for scenarios when you want to click inside that custom button that was put inside your grid but you don't have a means to otherwise click on it. While ancestral path and its subsequent count is a list that starts with its parent and its parent's parent, etc., all the way up to the parent form. It's great for exploring the object tree as well as confirming where you're at in it. These access methods are especially helpful in WPF, as by its nature, WPF is one of the most easily customizable Windows UI languages. The developer could, with minimal effort, embed several controls inside several other controls and have them all packed inside of a grid cell, all of them created on the fly. As such, for those scenarios, since we cannot easily accommodate for all of them, we expose the ability to handle them through property access methods and custom properties. Another expansion of these methods would be the subitem versions of these base 3 methods. These as well have been first implemented on Test Automation for WPF, but will be expanded into our Windows Forms suite. They use an easily discoverable enumeration to define the type of subitem as well as an identifier to narrow it to the specific subitem. The subitem type and identifiers are the ones that are used during recording when you interact with them in some manner, such as activating a cell, selecting a tab, clicking on a date in a calendar. So while you're recording, you're given all this information, but now you can also dig into those properties of those subitems through here. I will now demonstrate several uses of each and ways of discovering them. We're going to go back to our original sample. In this sample, we're going to assume that one of the calculations that we wanted to do is based off a column that's hidden. So how would we get at that column? Let's start off with WPF. We're going to go to the window and get back to our grid. So that's SWF table. And that was our grid. So let's set that back to our grid. As this is on the main action, not the sub action. We're going to comment that action. So then we have access to the grid. We can do grid dot get any property. I'm going to go on knowledge I do know offhand, but we'll get into discovery mode later. Display layout dot bands sub0 dot column columns dot count. We'll call this count columns equals. Let's do a quick message box of count columns. See what we have. I believe there were 7 visible. But you wouldn't know that from looking at the sample. In actuality, there appears to be 23. Okay, so we know what the columns are. What names are there? How do we access them? Let's do a quick loop. Column equals 0 to count columns minus 1 to calls equals calls and Now we could build in that column as an index to our string, and we'll do dot key. Make it a little bit more readable. dbcrlf. Then do a quick run. So looking through, and it's like, okay, it was reorder level. That was the column that I knew that it's being used in our calculations, but I didn't have it offhand. So we're going to hit close. So now if I want to just get a value out of it, you do grid dot get any property, rows sub 0 dot cells sub order level. Because any of the strings you could just pass in, if it's a string key like this, dot value, and we do a quick message box. I'll just put a little breakpoint here so it doesn't continue on. And we can see that the value of the first row is 65. Okay, but what if I want to see all of them? Well, grid dot set any property. And again, we'll just do display layout dot band sub 0 dot columns reorder level dot hidden is false. Now here's something that regularly trips me up. Perhaps it's just because I'm more used to coding in C#, but when to put parentheses around parameters and when not to for a method. The general rule of thumb being is if you're using method's return value in some manner, you need to put parentheses around the parameters. Otherwise, you can't use them. If you have them wrong, it'll give you a syntax error. Now, if we look at our grid, well, reorder level is there. Now, I know these because I've been working with the grid for a long time as well as Test Advantage, but how would you end up finding them? Well, there's another thing that seems to be missing. There's no scroll bar. Now this, I know as the developer, I didn't necessarily like the look of having the scroll bar, and I made it wide enough so I didn't need the scroll bar. So how would you turn the scroll bar back on? Going to be off the grid. So let's go look up the grid properties. Get NA properties. Let's just do sprops equals. And we can message box sprops. It shouldn't matter to run that one again, so I'm just going to run. So there's the properties. Notice actually it's cutting it short. This is actually due to a limitation to message box. I'll show you an easy way to bypass this. Properties may want to actually be up there, but there are still a lot more. So since we do have it in debug mode and we are stopped there, let's go to our watch and we'll go add sprops. And there's all the values there. These are by default pipe delimited. Now it does make them readable, but probably you might want to make them a little more readable. So how do we end up doing that? Here's a little trick we can do. Replace, actually, that's props pipe with bb tab. Now we're going to do watch on that. We could actually just do this in line too. So we have this here. Now we can go a step further. Copy. Let's go to our data tab, since it now has tabs in it. We We can paste it right into our data table and make a data-driven script out of it if we wanted to. This is if you didn't already have Excel. If you had Excel, you could just go post them in there instead, and you probably wouldn't even have to have that step. Now it grabbed all the properties in the order that it found it. But let's say we want to have them by alphabetical. We could easily do that as well. Actually, probably a more valuable method would be to data sort. Let's do this on B1. Now we have it by data type. You can see all the defaultable booleans, all the boolean ones. And what we're probably going to be looking for is, oh, actually I was mistaken. It is on display layout. That's where most layout settings are. So on display layout, it's of type grid layout. You can see all that information there. So we can actually expand that a little further. Give another quick run. Now we didn't need the message box there. It's still on that breakpoint. Go down to the other one. Since it's set to the variable name, it's going to actually be based on the new data, although the data in here is not going to be. So we're going to have to repaste that in here. This time we'll just sort it on alphabetical. Scroll bars. Scroll bars is an enumeration type, and I'll show you where we can look that up in a second. But based on that, any enumeration, you go again, grid.set NA property. This one is going to be display layout dot scroll bars, lowercase b. And we're going to set that to automatic. I'll just move this up a little bit so we don't need that message box or the other setting property. Now we got our scroll bar down here. Now granted, these minor tweaks to settings like enabling scroll bars or making a hidden column visible when it's not doable through the UI might not be valid for every testing scenario, but I hope you can see the potential for the edge case scenarios that may otherwise be difficult to handle, such as verifying or validating calculations that are done based on hidden data. Now that we demonstrated get any property, set any property, and get any properties, as well as use index properties, both integer-based and string-based, and setting an enumerated value property, let's move on to custom properties and the sub-item equivalents of these methods. To do that, we'll move on to our WPF product line. Now for this demonstration, I'm using our WPF Samples Browser, which is probably one of the most concise examples that demonstrates the need for sub-item properties. It is in the XamGrid samples under Display Implicit Data Templates. In most grid scenarios, you'll see in any one column all the cells having similarly formatted data, and in each cell you'll have one piece of value type information. In this sample, you'll have a column that varies its formatting based on the data, friends, family, and coworkers, and each cell actually houses multiple different pieces of data. So let's get started. So we're presented with a challenge: how to actually get the data out of this cell. How would you normally approach it? Let's go to record. Let's do a verification point. Let's see what data is in there. Click OK here. I'll give it all rows. The data in here is a special data type. UFT doesn't know how to handle it. We actually look at it, but all it's going to give us is the type name. So verification point's out of the picture. Since we're still recording, let's go back to our application and click on it. Now we got the cell information that we might need. And let's get some cell data on this. So we'll do set cell data equal to get cell data I'm just putting this in here so I can put a breakpoint. The reason for this is I have a feeling the cell data is not going to be very helpful here. Let's go to our watch window. At this point, we wouldn't be able to continue. We know nothing else about our object. Where do we go? Let's say our developer told us that there's a property called full name. We can interrogate that. So we can go to our watch window, add, and we'll type in celldata.fullname. It's giving us object required, but it's also telling us it is an object. This sometimes happens when Qtp doesn't really know how to handle an object. There are certain objects that just don't pass well. So we can't actually access it this way. So we can't use a verification point, and we can't use get cell data. What's the next step? Well, let's try and see what properties we can get from this. Here, get subitem properties. Requires us to name a type. We'll give it that. We'll give it the subitem. Well, we could just use a subitem right here. Now let's switch this to sprops. So it's basically just going to be a string of properties. And we'll take a look at that properties. Here we go. For WPF, you can notice that we started using custom properties. You can see the denoted, they have TA custom property. They're always going to be the first ones listed. We have FW element, which is a framework element. X, Y, width, height, rect, content element, and I'll get into that a little bit later, type, and toString. Along that, we also have value. So let's go and take a look at the value of this property. Since we know it's an object, let's look at the properties of that object. So we have nickname, full name, department, error, item, and our two custom properties, type and toString. So that was one row. But just out of curiosity, let's look at all the rows. I'm going to change this a little bit, turn this into a, actually, save some keystrokes. Let me to save some keystrokes. I'll do my grid equals, copy this. I'll do grid here. Let's do a for loop. We're going to do row from 0 grid dot row count -1. We're going to paste in that, and let's switch this from 0 to our row. Now, let's message box for each one of them. We're going to hit run. So there's the one we saw before, nickname, full name, department, error. First couple are all the same. Now we have relation. And now we have email. So they don't even have the same property structures. So how do we actually verify these? So we have the property names, and they're all different. But at least we can access them. prove that, we saw a name for all of them. Let's do sNames equals sNames. And I'm going to copy this. Switch this from properties to property. And I believe each of them had a full name. And to make it a little bit more readable, we'll do CRLF, which is basically going to put a carriage return line feed between each of them. And there we have it, full names of each one of them. So we can access the data. Now we're getting somewhere. Now we can actually even take this a step further if we wanted. For the sake of time, I'm just going to paste in here and explain it. Basically doing what I was doing before, is getting the properties. On my next step, I'm splitting the properties. If you noticed, the format of the property string that we get from subitem properties is we have the name of the property, followed by a pipe sign, followed by the type of the property, and for the custom properties, we have another pipe sign and the denotion that it's a TA custom property. In between each of the properties is a carriage return line feed, so it can display cleanly. So right here, I'm splitting the carriage return line feed and turning into a list of individual properties. Now I'm looping through those properties here and splitting the individual properties by their pipe sign and just grabbing the property name, which is the first element. Since type and item were special properties, we're going to exclude them. We're doing what we did before of .row, but now we're doing .value and we're passing in the property name. And we're just building a string of all properties of property name equals property value. And overarchingly, we're looping through the rows. So if we hit run, and we can see the two strings actually, as it did before, the to string is basically just the type name, but that gives us something to capture on to distinguish the differences between them. And we have each of the individual properties: Mary, the nickname, the full name, department, for all the coworkers. We have relation for all the family members. And for the friends, we have their email addresses. So now we have access to all the data in there, and we can evaluate any way we want and build a nice clean test case scenario off of it. So we're able to get the data through the object model of the grid, through the cell. What if we want to go through the framework element tree? We can do that as well. I'm going to get rid of most of this, get rid of this. So I want to point out a distinction here. Let's go to get subitem property. Return this back to 0. FW element dot type dot full name. We're going to do the same thing, but on the base object. This is going to return the type of the cell itself. It's an infragistics.controls.grids.cell. The next one is the actual framework element, the visual representation of it. It is a different type. It's infragistics.controls.grids.cellControl. Okay, now based on that, I want to bring in one of my favorite apps here. Is an open source app called Snoop. It is invaluable for interrogating any WPF application. Now what you can do here, you can expand through the tree and it'll show all the objects there, or you can hold down Control-Shift and highlight any object and it'll bring it up into the tree. Now let's go over to, well, here's cell control. So it brought the cell control into view. And this is that same cell control that we can see in our Get Subitem properties. With that highlighted, we can see all the current values of the properties here if we want to interrogate anything. All the non-default value properties are highlighted. We can see that content presenter, that looks promising. Cell, infragistics.controls.grids.cell. Here's the cell property that we saw earlier. You can scroll through. There's our value. And there's the properties we pulled up earlier. Now, if I didn't explain, double-clicking on any of these properties when they're objects will open it up and expand and dig into this. So again, like I clicked on cell, it went into cell. We can go down into the tree further, and if we're using our Get Subitem property, this would be children sub-0, because it's the first child. This would be the children sub-0 of that one, and we could just dig right into this. There's also content element that was in that list before. What content element does is gets the first content presenter that it finds through the tree. So it's going to search a tree, comes to this content presenter. So we could skip a few of the elements if we wanted to. And underneath that, we'd have another content presenter. And the content in there is our data again. So that would be another way we can get the data. Thus giving us several different means of solving our original challenge of how to access data from a custom templated cell when neither verification points or get cell data would apply. Just in case you're trying to Google Snoop and getting Snoop Dogg, the link for it's over down below. Or if you want to Google it, just make sure to put Snoop WPF or Snoop UI Spy or something along that line, and you should be able to get it just fine. Again, I highly recommend if you're doing any sort of custom work or working with WPF in general and need to do some heavy testing on it, is a very good app to have.